The South African Mathematics Foundation administers a number of mathematics competitions, and amongst them are the Olympiad competitions, which are called the South African Mathematics Olympiad, SAMO competitions. These competitions are run every year, and for juniors and seniors. Today, we are going to unpack the paper that was set in 2025, the senior paper, the second round. There are 3 rounds. We are going to do the second round competition today. So let's go straight to that. All right, as you can see, it's the SAMO Senior Round 2, 2025. Okay, so let's go to the very first question, which is which says, find the value of 2025 all squared minus 2025. Well, you can see there are only 2 numbers here. And it looks rather complicated, but it'll help a great deal if we use symbols for these numbers and do some mathematical calculations. So if we let say let A equal to 2025, there are only 2 numbers, yeah, and B equal to 2020, then what we have here is A squared minus 2AB plus B squared. Now this is a very familiar object. It is none other than A minus B all squared. And A minus B, as you can see, is 5. So the answer is 25. See, mathematics is so powerful. You don't have to calculate all these things and square them, subtract and add. Just simply use symbols and equations, and you can come to solutions very quickly. All right, so let's get on to the next question. Question 2 says the following. If 2 to the power of x is equal to 8, and 8 to the power of y is equal to 16, and 16 to the power of z is 32, determine x, y, z. All right, let's see, maybe you can calculate. If 2 to the x is 8, let's bring them to the same base. So 2 to the x is equal to 2 cubed, so that says x is equal to 3. 8 to the y is equal to 16. Bring all to base 2, so you'll have 2 cubed to the power of y is 2 to the power of 4. And from the third law of indices, this is 2 to the power of 3y equals 2 to the power of 4. So 3y is equal to 4, which means that y is equal to 4 over 3. Okay, that took a little while to calculate. And here you got 16 to the power of z is equal to 32. So in the same way, if you make this 2, we have 2 to the power of 4z is equal to 2 to the power of 5. That implies that 4z is equal to 5. or z is equal to 5 over 4. And the problem is to find x, y, z. We found each one of these. So we got 3, x is 3. Let's make it into a fraction. Y is 4 over 3. And z is 5 over 4. The 3's cancel. 4's cancel. And x, y, z is equal to 5. Okay, this is a simple problem involving indices. So we found that x, y, z is 5. I usually have the answers also in my PowerPoint, and I expose them after I solve the problems, just to check to see whether I have a new solution or to confirm the solution that I got is the correct one. So if you look at, in this case, there it is. It's all exactly the same as I've done. Final answer is x, y, z is equal to 5. All right, so let's go to question 3. Question 3 says 5 apples and 5 bananas are worth the same as 2 bananas and 11 apples. Um, so it's all a question of money now. How much are apples worth? How much are bananas worth? So let apples be worth A for apples, A each. And bananas, we can call them B. These things have been chosen nicely, these fruits. So you can get A and B. So we've got 5 apples are worth 5A, 5 bananas is 5B. So together, right, they are worth the same as this equals 2 bananas plus 11 apples. Right? So you've got, this is the same as that, the price is the same. So let's say, how many apples is a banana worth? Let's bring all the B's to one side. 5B minus 2B is 3B. And then you got 5A, 11A on this side. So 11A minus 5A is 6A. So therefore B is equal to 2A. So how many apples is a banana worth? A banana is worth 2 apples. So the answer is 2. 1 banana is worth 2 apples. Okay. So let's go down to just see what the solution says. Okay. So let's get on to the next problem, which is question 4. Question 4 says, you've got a figure here. It shows a dark shaded cube partially enclosed by a smaller light shaded cube. So there's a cube sitting inside here. It's a cube. Okay, so what are the dimensions? This dark cube. Well, you've got 4 this way, and you've got 1 on the side, 1 on the side. So this cube is 2 by. Its sides are 2. All right? Right throughout. And it's sitting inside a 4 by 4 cube. So it means that the height is 2. So the bottom is completely covered by these blocks. See? They are the gray blocks. So you got the black cube and the gray cube. And this gray cube it should have been completely covered, but some of these tiles or these cubes have been removed. So the question is now, there are no cubes missing on the faces not visible in the picture. So whatever picture you have, whatever cubes you can't see, the faces you can't see, there are no cubes missing. All right, so how many extra light shaded cubes, how many more cubes are needed to enclose the dark shaded cube and complete the large 4 by 4 cube? So in other words, fill the missing cubes. Now this is not easy. It's a three-dimensional problem and you have to visualize it. So we can try to make it simpler by counting the number of cubes you have to put in each layer. There are 4 layers. So this bottom one is layer 1. The second one is layer 2. Third one is layer 3. So let's count how many more cubes you have to put in each layer. The number of cubes to add to, let's do them one at a time. Layer 1. Well, at the bottom, there's only 1 cube to add. See, those which you can't see, they are filled by these gray cubes that were said. The only thing that you have to add 1. Layer 2. Now here, I only have to add 2 here. Just these 2. This is the second layer. Starting from there, 1 in the corner. So you have to put 2 there. Layer 3. Oh, now there are quite a few missing here. We've only got 2 there. So I have to put 2 on this side, another 2 on this side. That makes 4 and 3 this way. So there are 7 to put here because I need to put layer 3. Yeah, so you have to put 2 here, 3 here, 5 and 2, 7. See? Layer 3, you have to put 2 this way and 3 this way. That makes 5. Another 2 there. 7. So layer 4. Okay, you only got 4 there. Altogether, there are 16 on the top layer. So it's supposed to be 12. And there are 4 of them which are put in. So the total is, the answer is, you add up all these things and you get 22. 10 plus 12. Okay, so that's the answer that we get. Let's check to see whether the answer that I worked on some time ago. Yeah, you can see it's the same thing. In fact, it's exactly the same thing. Okay, we go on to question 5. Lisa's bucket weighs 21 kilograms when full of water. So you got the bucket and the water. So when you weigh the bucket together with the water, it's 21 kilograms. Then she pours out half the water from the bucket. The bucket and the remaining water weigh 12 kilograms. Now, what is the weight of in kilograms of the empty bucket? Okay, so you need to calculate the weight of the bucket. So let's call the weight of the bucket, let B. be the weight of the bucket. And the water, let's call it water, W at least. When we say water, we say full water, okay? And the water in full bucket. So when it's full of water, you got B plus W is equal to 21. So if you pour out half the water, the bucket still is there, but the water has been reduced to half of its original amount, and the weight now is 12 kgs, right? And the question is, what is the weight of the empty bucket? So you need to calculate the bucket. To do that, you have to eliminate the uh, the water. So how do you do that? I can multiply this by 2. Right throughout. 2b plus w is 24. And now I've got these two equations. The w can be eliminated. We need to calculate the bucket only. So we can eliminate by subtracting. So 2b minus b, subtract that ways, so I don't have any negatives. And w minus w is 0. 24 minus 21 is 3. And there we have the answer to that question. A bucket weighs 3 kilograms. And if you want to check see whether this is, yeah, so you see 3 kilograms. I've used some other argument here. You can read this without having to use symbols, just logic. You can read that and see whether you can make any sense out of it. Okay, now we go on to question 6. The sum of the digits of a 2-digit number is 7. If the smaller new number is created by swapping the digits of the original number, then the new number is 976. So you got the product of two-digit numbers is 96. I mean 976. So why don't we factorize 976 to see which 2 digits? 4 goes into this. 4 goes into this as well. So therefore 976 is 4 times 4 times 4 times 61. That is 16 times 61. And that is the only way you can write it as a product of two digits, the digit numbers. Because you got when you swap the original 2-digit number, you're going to have another 2-digit number. Okay, so, and they say, what is the original number? So they say the smaller new number. Okay, so the new number is smaller, and therefore the original number is of these two numbers, the original number will be 61, because the new number is smaller. And if you check all the other things, they say the sum of the digits is 7. We didn't even use that. 1 plus 6 is 7. You can see it. And when you're swapping it around, if the smaller new number is created by swapping the digits around, so 61 and 16, the product of the original number, yeah, so you take the original number and you swap it around, like as we have done here, and you multiply the two, and you have. So the answer is 61. But now, if you didn't do it like this, we could have used mathematics using symbols and so on to solve the problem. And I've done it here. You can see it's very complicated. So this is one of those cases where the mathematics is more complicated than the common sense. Very often you have to use common sense to solve your problem. Mathematics can be used as a tool to solve it, but it may be much more intricate. Like in this case here, if you read this thing, it's let the number be 10a plus b. When you got a two-digit number, it's always of the form 10a. It's the hundreds, the tens unit, and the units part. So if the tens unit is a, then it's the value of the number is 10a plus b. Right? And then you swap it around, then that it becomes a plus 10b. And they say that if you multiply these two numbers, you got 976. So you can see I've got those equations there, and we know that the sum of the digits is 7. Let me not hand wave here. All right, so this is 10a plus b, and then you swap it around, it's a plus 10b. And if you multiply these two, you got this. But we knew that the sum of the digits is 7. So you can take one of them, say b, it's going to be 7 minus a. So you can replace the b with only a's here, so you have only one unknown. That's a good trick, right? Eliminate unknowns by replacing them in terms of the others. And then you get only a's here. And then you get a rather complicated quadratic equation in a, and have to just observe that 81 goes into all these. This is 81 times 7. This is 81 times 6. And then you get a factorization. So a is equal to 106, and so on. All right. So you can see that is far more complicated than the common sense one. Let's now get on to the next problem. Step 7. Two circles are enclosed in a rectangle measuring 9 by 5. So you got a circle here, a circle, they're covered by this rectangle. What is the distance between the centers of the two circles? So if you take this as a center, so what is the distance between these two? Well, you can see that this is 9 by 5. So this is 5. But this is the same as the, if I join the tangent, the contact points to the center, you will see that you've got a straight line that goes through the center, right? The same thing here. The point is the diameter of the circle is 5. So the circle has got radius 2.5. You can see the diameter is the same as that. So these are the two centers. Let's draw a long line here to connecting the centers. What happened here? Okay, so you connect the two centers. And you will see that this whole thing is one straight line here. So we need to work out what this distance is. And that's not very difficult because this part here is the radius, in the center. The diameter is 5, so the radius is 2.5. So you got another 2.5 here. So we are interested in the distance between the two. So the distance that we are looking for plus 5 plus all this is actually equal to 9. So the answer is 4. This whole line here is equal to 9, you see. So this is the only unknown in between, the distance between these two. So if you call that x, you'll see x plus 2.5 plus 2.5 is 9. I didn't give any name to it, I just said distance. All right, so that is the solution to that problem. Question 7. Let's get on to question 8. Okay, there's our solution, which is exactly the same as what I said. Question 8. I hiked into a forest at 4 kilometers per hour. Okay, so in all these distance time problems, I like to draw some diagrams to represent the paths that these objects take. So you've got, it's a forest, this whole thing is a forest, you're walking through this, and your speed is 4 kilometers per hour. So this way, it's 4 k's per hour. And then return the same route at 3 k's per hour. So how many kilometers into the forest did I hike? Okay, in other words, you need to know what is that distance. What is the distance that you had actually walked? But the whole trip took 3.5 hours. So let's see how long it took him to go up and how long it took him to go down. And remember, speed or time is distance over speed. And speed is distance over time and so on. So yeah, you are given the speed. So I can use this to calculate the time. So you have the upward journey, the onward journey takes d over 4 hours. The distance is d, the speed is 4, so this time is 4 hours. The return time, same distance, d, but now you're traveling at 3 kilometers per hour. So the time taken is that. So the total time taken is the d over 4 plus d over 3. And the round trip took 3.5 hours, 7 over 2. So you can calculate d. I'm not going to do that. You'll see that d is equal to 6 kilometers. Right. So the next, so there it is. I didn't do it, but the answer is here. Okay, let's get on to question 9. Question 9 reads, two tractors are plowing a 3-hectare field. So you got two tractors. The older tractor, let's call it O, takes 10 hours to plant 1 acre, 1 hectare. And the maybe you shouldn't call it. Oh, it looks like a zero. Okay, let's do that. And the new attractor, takes 5 hours. Okay, now both attractors work together for 2 hours. Now there's always a trick here. You see, you bring it down to what happens in 1 hour. So in 1 hour, the older, in 10 hours, it finishes 1 hectare. So uh, covers 1/10 of an hectare. I think the symbol for hectare is HA. All right. And the same with the newer one. But the newer one, it takes 5 hours. So in 1 hour, it'll cover 1/5 of an hectare. Why do we do this? Because they're working together now. So working together, you can see they are going to do 1/10 plus 1/5 in 1 hour. These are hectares, 1/10 of an hectare plus 1/5 of an hectare, right, in 1 hour. But they actually worked for 2 hours. They worked together for 2 hours. So it's 2. Okay, I'll just put a colon here. So therefore, uh, they cover for 2 hours, 2 into 1/10 plus 1/5. 1/5 is 2/10. So you got 1/10 plus 2/10 is 3/10. And 2 times 3/10 is 6/10. So they cover 6/10 of an hectare, or 3/5 if you want, when they work together. But then what happened? The older tractor breaks down. Okay, they only covered 6/10 of a hectare. They had 3 hectares to do altogether. So remaining is unplowed. Area is 3 minus 6/10, which is 2.4. 6/10 is 0.6, 0.6. Okay, so you've got this amount of hectares. Now the old guy, the old tractor broke down. So now it's all left for the new tractor to finish the job. So they say, how many hours is it going to take the newer tractor to complete the plowing? So the new tractor takes 1 hour, or 1/5 of an hour, to do 1 hectare, right? So it does 1/5 of an hour to do 1 hectare. You got 2.4. New tractor covers, right? So it does. It takes 1 hour to cover 1/5 of an hectare, or 5 hours to cover 1 hectare, or 5 hours to cover one hectare. So it's 5 times 2.4 hours. right? To cover 1 hectare, it takes 5 hours. You have to cover 2.4, and that is 12. So this is the answer to question 9. Check. Right, you can see the answer is 12. Let's look at what question 10 is saying. Question 10, it says, in how many ways can 6 students, A, B, C, D, E, F, sit together in the first row during assembly if students A and B must sit next to each other? So A and B sit together, and C and D also sit next to each other. So E and F, they can sit wherever they like. All right, so in how many ways can this be done? One neat trick is to tie these people together so you don't separate them, right? And regard them as a single person. So you move two together along the seats. It's a single person. So now you've got 4 objects. We'll call it objects, namely these bundled students, the E student, F student, and this other bundled student. Namely this, can be arranged in 4 factorial ways. And, you should know that the number of ways of arranging n objects is n factorial, which is 1 times 2 times 3 times 4, all the way up to n. Okay, so, and this is 1 times 2 times 3 times 4. Right. But now, I could have had with BA, you also have 24. Or you could have had AB and DC. Or you could have had AB or BA and DC. So actually, these two people, each of them can be arranged in 2 ways. You just switch them around. So there are 4 different ways in which these people can be arranged. You can have a BA or AB, CD or DC, and you pair them off like that. You have different new arrangements. So therefore, answer is for each of these arrangements, there are 24. For each of these situations, for this one here, there are 24. For every one of them, there is 24. So it's 24 times 4, which is 96. For each of them, there's 24. And if you switch a BA around, there's another 24, and so on and so forth. Okay, so the answer is 96. Let's just check to see. Ah, there it is. Okay.